what are cosmic redshifts? What is a redshift? Have you heard of the Doppler effect? So redshift is about the application of the Doppler effect to light. So now let us go to let me put an illustration of the Doppler effect on the screen, and then let me explain what redshift is. So Doppler effect. So here we have the Doppler effect with a sound source. Okay, let's say you have two cars. Let's say you have a start. Okay, with a train, right? We are all familiar with the Doppler effect with a train. So when you have a train coming towards you at a high speed, and the train blares its horn or siren, you're gonna hear a very high pitched sound as it's coming towards you. But the moment the train passes you, you're standing on the platform and the train is coming towards you, it's going to be very high pitched sound. The moment it passes you and it starts going away from you, the sound changes in frequency and it becomes a lower pitched sound. That is the Doppler effect. And the reason for that is because when the train is coming towards you, the sound waves are compressed. That's why they sound higher pitched, or they sound as if they have a higher frequency, because they do have a higher frequency from your perspective. And when the train passes you and it goes away from you, then the source of the sound is moving away. And that's why the sound waves are stretched out and they appear to have a lower frequency. So that's how the Doppler effect works with respect to sound. And the same thing happens with light. So when a light source, so light is an electromagnetic wave. This wave is going to have a frequency or a wavelength. And when a light source is moving towards you, those light waves are going to get compressed, squashed, and they're going to have a higher frequency and a shorter wavelength, which means the light will be shifted towards the blue end of the spectrum. You know, Vibgyor, right? Violet, indigo, blue, yellow, orange, red, the seven elements of the spectrum. So when light is when the light source is moving towards you, the light is going to be shifted towards the blue end of the spectrum. That's called blue shift. And when a light source is moving away from you, then the light waves are going to get stretched out, and the light is going to be shifted towards the red end of the spectrum, and that is redshift. So when you observe redshift in the cosmos, when you observe, and how do you know that something is redshifted? So there are certain characteristic lines in the spectrum. In spectroscopy, you know that that each element has certain transitions which produce characteristic lines in the spectrum. Wanna see what a spectrum looks like? Okay, let's look at the spectrograph. Spectrum. Let's see what a spectrum looks like. Spectral lines. So these are spectral lines. Okay, every gas, you have a star in which you have different elements. You have hydrogen, helium. There's gonna be other elements also. So they're gonna have various lines in the spectrum, and we can break down these lines into the element into their components using something called a spectrometer or a spectrograph. So you have various spectral lines and all that. So now we know that each spectral line has at which frequency it exists. So for example, if you burn sodium, it produces a very characteristic line on the spectrum, and we know what is the frequency of that. But when you observe that line in the spectrum of light that's coming from a galaxy, you're going to see that it's not at that frequency, it's at a different frequency. If it is shifted towards the red end of the spectrum, then that galaxy is red shifted. If it is shifted towards the blue end of the spectrum, it is blue shifted. So when you find that light is red shifted, it means the galaxy is moving away from you. And depending on how much it is red shifted, you can determine how fast it is moving away from you. And similarly for blue shift. So that is what a red shift is. That's what the blue shift is. How do we know galaxies are rotating? Because if you see the light coming from one end of the galaxy, it's going to be either red shifted or blue shifted. And the other end, if this part is red shifted, this part will be blue shifted. And if this is red shifted, this will be blue shifted. So you know that one end is moving away from you and one end is moving towards you. That's how we know that galaxies rotate. And then, yeah, that's how it goes.